In this video, I will share how to use screw gauge for measurement of thickness of very thin objects. Before sharing the procedure for measurement of thickness, let me briefly introduce the instrument screw gauge. Screw gauge has mainly two parts, fixed part and movable part. The movable part can be rotated over the fixed part. A scale is calibrated on both the parts, fixed as well as movable part. The scale on the fixed part is called main scale, that is generally calibrated in millimeters. Each main scale division is of 1 millimeter. The scale on movable part is called circular scale and it has total 100 divisions of equal width. Final reading from the screw gauge is calculated by the relation R equal to X plus N into LC. In this relation, X is main scale reading, N is circular scale reading, LC stands for least count of screw gauge. For calculating least count of screw gauge, the movable part is given a number of complete rotations and the linear distance moved by the movable part is noted down. The ratio of linear distance moved by the screw to the number of complete rotations is called pitch of the screw gauge. For example, suppose linear distance moved by the movable part is 5 mm. When 5 rotations are given to it, then pitch of the screw can be calculated to be 1 mm. Least count of screw gauge is defined as pitch divided by total number of circular scale divisions. Using the value of pitch as 1 mm, least count of screw gauge can be calculated to be 0.01 mm. Suppose thickness of this object is to be measured. The object is tightly held by rotating the movable part of screw gauge. Readings from main scale and circular scale are noted. Main scale reading is noted as the reading that is just visible nearest to cap of the movable part. In this case, main scale reading just visible nearest to cap of movable part is 5 mm. So main scale reading can be written as x equal to 5 mm. Circular scale reading is noted as the circular scale line that coincides with reference line of main scale. In this case, 12th circular scale line coincides with the reference line of main scale. So circular scale reading can be written as n equal to 12. Using main scale reading x equal to 5 mm and circular scale reading n equal to 12, final reading can be calculated to be 5.12 mm. Hence, thickness of the given object is 5.12 mm. Thank you.